Hello friends, welcome to Mech Studies. Let's learn about buffer tank in HVAC system. We will learn here basic design, working philosophy, sizing, applications and many more. So what does buffer mean? Something that provide protection against difficult situations. Let's try to understand with practical example. We all get salary in every month. And what we do? We spend our salary in rent, EMI, tool plan, daily expenses, tax, social responsibility, and what are the required things. So what we do? We just keep some amount as a buffer so that in case of any emergency we can utilize that money. In HVAC system, the buffer tank is used in the same philosophy and we will learn in detail furthermore. Buffer tank look like this and it is used in many HVAC system. For common, we can understand that buffer tank is used in geothermal heat pumps, in chilled water systems, in boiler systems. Let us try to understand the buffer tank concept. This is basically a chiller, and chilled water is produced in the chiller, which goes to air handling cooling coil through pipe. And after heat pickup, the chilled water will be hot and it will return back to the chiller once again through a set of pumps. Now the number of pumps depends on the project and number of chillers, AHU, everything depends on the project to project. Here we have shown a very simple schematic for better understanding. Now fresh air or the return air, it passes through a set of filters and cooling coil and through a circulating fan it goes to the areas which is to be air conditioned or where the air conditioning load occurs like a room or a building. Now if there is a load fluctuation in the building, what will happen? It's simple. The compressor will not understand and it will just simply on and off. So it will result in short cycling. Short cycling means the compressor will on and off very frequently. It will result in efficiency, wear and tear, and it will problem for the maintenance. So what we'll do? We will introduce a tank that is called a buffer tank, which will resolve our problem. Means the system will be efficient, there will not be any problem for wear and tear, and the maintenance issue will be resolved. What is buffer tank? A buffer tank is a tank that is used as a buffer between the cooling or heating source and the distribution system, ensuring a steady supply of heated or cooled water. So this is basically here the cooling source and this is the distribution system and here is the buffer tank. Now let's see the definition of buffer tank. A buffer tank is a storage tank that helps to manage the temperature, volume and flow of water in HVAC system, and it is mainly applicable where load fluctuation happens. So how does it looks, especially in project or in 3D model? We will check here. So let us try to see how the 3D model of a buffer tank looks like. So this is basically a buffer tank and you see the 3D model. Yeah, and it can be vertical, it can be horizontal, and
See, this is the nozzle. Here is the nozzle. These are the nozzle, and this is the nozzle. And opposite side, if you see, here is one nozzle, and here also one nozzle, and many other nozzle for instruments. These are the instruments. And if you see, for the vertical buffer tank, these top nozzles, these are for hot liquid, and the bottom nozzles, these lower side nozzles, these are for cold liquids. And the bottom side, if you see, this is the drain connection, and the top side, if you see top side, there will be a vent connection. So this is basically a buffer tank. We will see details later on.
There are various materials are used for buffer tank. However, SS316 or SS316L is most common material for buffer tank. However, it depends on the project to project and the selection will also based on that. What does a buffer tank do? It adds volume to a system so the heat pump or chiller operates efficiently. If you undertake system volume calculations, you will see that the system meets the minimum system volume simply through the pipes, equipment, and accessories. So, in summary, we can say to maintain system efficiency, to reduce wear and tear, to improve overall comfort and conditions, to prevent short cycling, to maintain consistent temperature throughout the system. Protection against stratification. Buffer tank help to prevent stratification of water. We know that hot water rises to the top and cold water to the down. So there will be a uneven temperatures and it basically reduces the efficiency. And the tank allows for mixing of water and maintains an uniform temperature throughout the system. How do buffer tanks work? Buffer tanks store excess heat or cooling energy generated by the system. Now the system demand can be low or can be high based on the requirements. When the system demand is low, tank absorbs the extra energy, preventing the equipment from short cycling or frequent on-off of the compressor. When the demand increases, the stored energy is released and ensuring a smooth and efficient operation. The tank acts as a thermal reservoir, balancing the load and minimizing the fluctuation in temperature as well as flow. So, this is the basic working philosophy of any buffer tank. See a very interesting thing about buffer tank. If you observe closely, this upper portion is reddish and down portion is bluish. This upper portion indicates hot water and down portion indicates cold water. It is the natural phenomenon. If you put very hot water in a cold water glass, we will see the hot water will be on the top side and cold water will be on the downside due to the density differences. Now, the same philosophy is applicable in buffer tank, and there is an imaginary barrier between this hot and cold section. Now we see that the location of nozzles and the upper portion here, these are not good. This is not acceptable in terms of efficiency and that effectivity. But the downside, you see, this is a good. And there are baffle plates within this tank for proper mixing as well as proper heat transfer. Sizing of buffer tank for chill water system. So the steps are as follows. Determine the capacity of chiller. Say it is 600 kilowatt. Then determine the required system volume. This data will be given by chiller manufacturers. Chiller manufacturer can differ in their system volume needs Normally 4 to 7 liters per kilowatt seems to be normal ratio for air conditioning system comfort applications. But for multifunctional chillers, it can be reach up to 10 to 11 liters per kilowatt. So we can consider 5 liters per kilowatt for our calculation. Required system capacity will be our chiller capacity multiplied by 5. So 600 by 5 equal to 3000 liters. Now after determining the required system volume, we have to calculate the actual system volume in liters. Actual system volume is equal to piping volume plus terminal equipment volume. We have to calculate this as well. Now let's try to understand how do we calculate the actual system volume like piping, fittings or equipment volume. So this is basically chilled water system volume calculation. Here what we have to do, we have to give all the line numbers, its diameter, length, all the connections, fittings, everything's like T here, what's the reductions, everything, elbow. So everything we have to give input and we have to calculate the volume using simple formula. Once we did, we will understand that total volume of piping and fittings, how much it is coming excluding equipment. Say for example, it is 1000 liters. Now after that, we have to get the volume of the equipment. Here we have considered fan coil units. You can consider any other equipment which is relevant for our application. Model number, everything, this is for reference only. Say here the total volume we will get from the equipment data sheet. So this is the data sheet. So for example, let's see its volume of equipment is 500 liters. This capacity is for example only. So actual volume will come 1000 liters for the piping and fittings and 500 liters for equipment. So total it comes 1500 liters. This is for example purpose only. Let's see actual system volume comes 1500 liters. We have already got the required system volume and actual system volume. Let's find out the volume of buffer tank. Buffer tank capacity in liters. Buffer tank capacity equal to required system volume minus actual system volume. So required system volume is 3000 liters and actual system volume is 1500 liters. So 3000 minus 1500 is equal to 1500 liters. So this is the capacity of the buffer tank. Buffer tank in geothermal heat pump. Let's try to understand a geothermal heat pump. This is the circuit. This is geothermal heat pump and the hot water from the ground comes into the geothermal heat pump and going to the different zones. Zones means the conditioned space and it is through different equipment like air separator, heat source pumps, etc. There is an expansion tank as well to pressurize the system. And hot water becomes cold and it is going through geothermal heat pump and from the geothermal heat pump it goes to the ground. Now if there is a load variations in the system like zone 1, zone 2, zone 3 or zone 4, then what will happen? The demands will be different. So the thermal storage requirement will be different and the geothermal heat pump will have a short cycling. It will have a problem to provide the required thermal storage capacity. Its efficiency will be down and operating cost also will be increased. Now, if we add an extra buffer to the system to meet the load variations, then there will not be any problem. This is simply called as buffer tank. Sizing of buffer tank for heating system. There is a formula V equal to M into QH minus QM by T into 500, where V is equal to buffer tank volume in gallons, M is equal to desired heat source, minimum runtime or on cycle time minimum, QH equal to heat source output minimum in BTU per hour, QM heat output for minimum system load in BTU per hour, T equal to tank temperature rise delta between supply and return in degree Fahrenheit. Sizing of buffer tank for heating system. We already know the equation. Now let's try to solve a problem. A heat pump that outputs a minimum of 80,000 BTU per hour with minimum cycle time 10 minutes and smallest zone is 10,000 BTU per hour and the allowable temperature differential is from 90 degree Fahrenheit to 100 degree Fahrenheit. From the equation, we are clearly seeing that QH is the heat source output minimum, here 80,000 BTU per hour. Then the desired heat source minimum runtime, M equal to 10 minutes, and smallest zone is 10,000 BTU per hour, and the allowable temperature differential is 100 minus 90 equal to 10 degree Fahrenheit. Now, putting all this value in the equation, we get V equals to 10 multiplied by 80,000 minus 10,000 divided by 100 minus 90 multiplied by 500, which gives V is equal to 140 gallons. So how do you understand that your system needs a buffer tank? Step 1. Determine the minimum system volume requirements of the heat pump. Let's assume minimum system volume is 300 liters. Step 2. Calculate the actual system volume. Let's see an example. The pipes have a total volume of 70 liters. Radiators and underfloor heating count for 80 liters. Cylinder coil and other components add up 40 liters. So total 70 plus 80 plus 40 equals to 190 liters. Step 3. Minimum system volume requirements minus actual system requirement or actual system volume equal to 300 minus 190 equal to 110 liters, and we have to provide a buffer tank in the system. Let us see a scheme for buffer tank. This is the buffer tank. This is the hot portion and this is the relative cold portion. This is heat source loop, the loop between boiler and the buffer tank. And this is the load loop. That means the system and buffer tank. So from the schematic, we understand that hot water or hot liquid will be on the top side and downside will be the cold water. From that example, we see that the hot water it is 80 degrees centigrade and that downside cold water it is 40 degrees centigrade. This actual photograph, this is the nozzles and for the hot water and this is the nozzle for cold water. There are couple of maintenance points we have to keep in mind for buffer tank like regular inspection, check if any signs of leaks. So it is check positive if any corrosion we have to provide. If any damage, cleaning the tank and its components whenever required or based on the schedule. Check the insulation if it is in good condition. Tank pressure and pressure relief valve to be checked. Tank temperature and thermostat also to be checked based on the schedule.